Scenic route there. We saw a lot more of the park than we should have, but wasn't it nice? You were all looking out the window, right?
Yeah.
Oh, who saw the deer?
There was deer?
Saw some deer? Okay. Okay, so
It's not fun.
let me get you oriented here. We're still in Monroe County, right? We're in Mendon County Park. We're only, believe it or not, we're only about 7 minutes away from school. We took the scenic route. And going back about a million years or so ago, this area is thought to have been covered with about maybe a mile or two thick of ice. So imagine, you know, from here looking up, having a mile of ice on top of us. And north is that way, right? So towards Canada, headed this way. So that ice, what happened was, for many, many years, there was more snow piling up than there was melting. And as it piled up, it compacted and compacted and compacted until it became ice. And then eventually it built up and it started to spread out in all directions away from that area where it was building up. And so then the area near Hudson Bay, if you can picture where that is on the map in Canada, that's where we think it kind of began. And then it moved southward to about near about where the edge of New York and Pennsylvania are. Almost all of New York was covered with glaciers. And then probably by about 11,000 years ago is when we think that the ice had completely melted out of this area and then revealed the landscape that had been completely changed by the glaciers that were above it. So Mendon Ponds is very unique in that we have many, many, many glacial landscape features all in a tight space that we can hike around and we can see this really quickly. I want to get you oriented right now, and we're also going to use the topographic map so that we can understand how we would use this if we wanted to go hiking or if we were planning a trip. It could be cycling or running. So we are right now, we're at this spot right here where this little triangle is. And the next stop is going to be at the end of this road. And so by looking at this, what's going to happen? Like, what's the path going to be like? I want you to talk to the person next to you right now for a second and tell them what you think it's going to be like. What did you guys decide was going to, by looking at the map, what's your prediction about what the path is going to be like? Okay, a variety of different levels. Let's hear from Josie. What did you come up? What were you thinking was going to happen? Okay, what evidence do you have that it's steep? Love your idea. And those are contour lines, right? When we have closest space contour lines, we know it's going to be steep. On here, it tells us our contour interval is 5 feet. So if I count the spaces, right, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. How many basketball hoops is that? 60 feet. How many basketball hoops piled up is that? 6, right? Basketball hoops 10 feet. So you're going up in elevation the same thing as if you had 6 basketball hoops stacked up. Okay, so we're going to go up there and we're going to stop and we'll be at the top of Devil's Bathtub, which is where our second stop is. Now I tend to hike not like super fast, but pretty quick. You need to keep up and not be dragging way behind. Trip is to realize that when glaciers shape the landscape, they make really big changes. That was just 60 feet or so that you just climbed up in elevation, piled up of sediment from a glacier. So that, you know, just gives you a sense of the scale of landscape changes. Now, one of the things that glaciers can do that other forms, a glacier is what we call an agent of erosion. Like a river an agent means a way of doing it, and erosion you probably know is moving things. And rivers can move things, wind can move things, right? People can move things, and glaciers have the ability to move things much bigger than, say, a river or the wind. And the rocks that you see over there, they weren't placed right there by the glacier. People moved them. But they came out of this parking lot. When they made this road in this parking lot, they came across those and they piled them up there. Now right now you guys are just getting into rocks, and normally I'd take you here a little bit later in the year where you'd have a little bit more knowledge. You know, I've got a child coming soon and I want to plan the trip. before the baby came because I didn't want to have to cancel the trip because I was home. So normally you would have a little bit more knowledge about rocks at this point, but I'm going to see if you can handle this. I think you're all bright people can do this. Right now we're studying igneous, right?
Yes.
And if we had igneous rocks, we would see things like crystals. What else would we see? Kind of textures. Rocks that have, go ahead.
Like small or fine crystals.
Love it. We might see small or fine. Some of them look like Swiss cheese, and we call that what?
Vesicular.
Vesicular. Some look like obsidian, and we might describe those as, thinking of the G word, Isabel's all over it, and Valerie, I love it, and Lindsay's all over it. Let's give Valerie a shot.
Glassy.
Love it, glassy, and pumice is glassy too, remember it's not shiny, but it's still considered glassy because glassy means you can't see any crystals. Okay, now, if we had a sedimentary, I know you learned a little bit about rocks before. Anybody know what evidence I might look for to find a sedimentary rock? Carolina, you know?
Layers.
You might see layers. I love that idea. Anybody else got any ideas? Thinking of an F word appropriate for school. Something that was once living and now it's not. And it's in the rock. You know what I'm looking for? Fossils. We might see those. And we might also see pieces of other rock. Like we might see little bits of sand all cemented together or pebbles. Those would be sedimentary. Now, metamorphic, you know, are a third type. And those are ones that are from heat and pressure. So metamorphic rocks, what they'll look like quite often is they'll be squeezed together and all the minerals will be lined up in one direction. And they often look like they have zebra stripes of different colors. Those are gneisses, the ones that you see, G-N-E-I-S-S. So those would be like the third type we'd look at. I would like you guys, in a second, you're going to, when I say green light, go, I would like you guys to go over there, and there's some big boulders over there. I'm going to want to see if you can work together and figure out what kind of rocks those are. And also, I didn't say green light go yet. And also, this is a chance for you're going to be looking down on Devil's Bathtub. We're going to go down there a little bit. We'll talk about what it is. It's a good chance to take pictures if you want. If you have your phone and you want to take a picture real quick.
When I was looking at the one over there, it had fine crystals, fine textured crystals, and it just, I don't know, it looked like igneous to me.
Okay, any other ideas? We all thinking igneous? Okay, these are, most of these are either, if we look at the one that Mara's sitting on and Allie, you can probably see, now they're weathered quite a bit, meaning that they've been changed and they're getting worn down. You'll be able to see that the minerals are sort of going in a line. These aren't the greatest examples of gneisses, but
Right
a lot of these
behind
are gneisses. And so here's what I want you to walk away with is that most of the rocks that we find in this area, like if you see the layers of rocks along the highway or in the creeks, they're going to be sedimentary. And these are igneous and metamorphic. Most of them are metamorphics. And where we find those kinds of rocks are more to the north of us in Canada, maybe to the north towards the Adirondack Mountains. And these are way too big to have been moved here by rivers. So they were moved here by something. We know that they didn't come from this area. They're kind of oddballs. They don't fit with all the other rocks that we see. There's a name for this. They're called glacial erratics. Can you say it? Glacial erratics. Love it. Okay. And what it means, essentially, is a big boulder that's been moved by glaciers and they're dumped. And you guys probably are familiar with, if you had Mrs. Harrington, I believe, has the class with the big rock outside there. Okay. That one out by her classroom, that's a big glacial erratic as well. Most of the ones that are in the parking lot by the tennis courts, a bunch of those are gneisses, some of them are limestones, but most of those are big rocks that have been moved by glaciers. If you look all around Henrietta, you're going to see that they're used for landscaping and such all around. They're these big giant boulders. They were too big to have been moved by a river, and they've been moved by a glacier. And then a lot of them have been moved again by people just for landscaping. They encounter them as they're making parking lots and such. Okay, so in a second, I'm going to lead us down these stairs. Just be careful on the stairs. There's usually wet leaves. And I've had more than one student slip and fall on there because they weren't really paying attention. It shouldn't be a problem, but again, remember, I'm going to go down. We're going to stop at the bottom.
There's a hold my hand, I'm scared.
You can do it, Melvin.
You a big boy.
Carolina!
A kettle lake. And the idea behind this, or what we think happens, is that the glacier ice pushed from the north, which is that way, to the south. And then when it was melting and breaking up, there would have been a big block of ice here. And then the glacier melts, and there's a lot of sediment that's being pushed by the glacier. And as it melts, the rivers of water that are coming off the glacier are going to carry sediment. And this area was a big block of ice that got buried by sediment all around it. So sediment on top, sediment on the bottom. And if you have it buried in sediment, it acts sort of like a cooler. Helps keep it cool. That keeps the cold in with all the sediment. It insulates it. So that block of ice hung around a lot longer than the other bits of ice. And eventually that block of ice melts out. The sediment that's buried on the top collapses in. And you got these walls of sediment all around it. So what happens is you've got kind of like a cup here, right? And that's the kettle idea, like a pot. So it's like a cup, and these things are called kettle lakes, and all the ponds here are essentially kettle lakes. So imagine a big block of ice, right, melted out, and this is what we've got. Now there's a lot of stories about why this is called Devil's Bathtub. You can read about them. Some people thought it was like the smell of it, sulfur smell from the decaying plants. I don't know. There's no real clear answer as to why it's called Devil's Bathtub. And a lot of people say, oh, there's a lot of stories like, oh, it's so deep that nobody knows what the bottom is. And that's not the case. Now, I've never gone out there and tried to measure it, but I can just tell you that in general, a lot of these kettle lakes tend to be fairly shallow because they were a block of ice that filled in here when they melted out. And you can see, too, that there's been erosion down the side, and the sediments come down, and the leaves come in, the trees have fallen down, and all of that starts to fill in the bottom of the pond as well. Okay, so in a second, we're going to make our way down the trail. I want to make sure you know where we are. Here's the deal. Along the edge here, we've got this whole rim, and we've got the low elevation here. We know that when it rains, the water always flows from high elevation to low, right? Clearly high elevation, clearly low, right? As it flows, it's going to carry sediments with it, right? We call that erosion. So erosion is moving sediments, and then eventually they come to a stop, right? Well, scientists want a word for that too. So their word for that is deposition. Deposition means to stop or make it pile up. Well, what you're looking at here is sort of the future of Devil's Bathtub. This too was a kettle lake. It at one time was deeper. At one time had water on the top and wasn't a swamp. So what happened, right? Well, the sediment from up there all eroded, got deposited, and you can see what's down in here. There's lots of fun stuff in here. I love to get down in here. And yeah, all of this. Now there's a word that we're gonna. Hey George, you want to taste it? He loves doing this. So you want to smell it? No. Great. Yeah. George, you gonna lick it? Okay. So. Okay. There's a vocab word that I'm going to want you to remember. It's called organic matter. Say it. Organic matter. That's what this is. It's parts of things that were once living, and this is full of it's a lot of wood and decayed leaves, and so the organic matter, it adds a lot of carbon into there. There's a rock that has a lot of carbon in it that a lot of us use for fuel to get our energy, electricity and such. You guys know what it is I'm talking about? Starts with a C. That's the one, right? So if this were to get buried deep in the earth and compacted together, there's a possibility that this in here could eventually become coal, right? It's got all the right material. It's got lots of leaves and trees, all these plants decaying and compacting together. Now generally you'd need to be in like a warmer tropical area where you have a whole lot more plant life, a whole lot more leaves, but glorious, what's it called? Organic matter. All right, so you're not going to forget that, I hope, right? It's like poop, right? Okay, let's make our way around. Need you to listen. All right. right, so now we're going to find another glacial landscape feature. It's called a kame, K-A-M-E. And here's the idea. Imagine where you guys are. There's a lake, and this is the top of the ice, right? So you've got a wall of ice here going into the lake. You with me? Can you picture it?
No.
Okay, so there's a lake here. This is the top of the ice, and there's a steep drop-off, like a waterfall. Okay, so the ice is real high. Remember, probably about a mile thick of ice here, right? Now, as it's melting, it's going to get smaller and smaller. So now, as it's melting, water's running off in little streams. It's carrying sediments, and it gets to the edge where there's a cliff, and it drops it, and it starts to pile it up. So it's going to pile it up, and when it does, it creates something that looks like a cone-shaped hill. Anybody see anything on this map that looks like a cone-shaped hill? Talk it over with somebody next to you, see if you can figure out where the cone-shaped hill is.
I have no idea.
What would it look like?
It'd be like circles and circles inside of inside
Yeah, where do you see one on there?
by the 474 number on there.
To the left of that, right?
Yeah.
Right underneath where, is it 6?
Okay, let's all stop. Jasmine, do you know where we're going to go? The cone-shaped hill, can you point to it? Where do you think we're going to go? I like your idea. Yeah, definitely. She said either this one or this one. Great idea. How did you know that was the cone-shaped hill? I want to hear her ideas. Okay, I love your idea. Lines are closer together. We got close contour lines as we go up. Kind of looks like a bullseye, doesn't it? So you guys recognize that as a hill. Okay, so do you think we're going to go up a lot of elevation or a little bit looking at that? A lot, right? We're going to go up a fair amount. And there are some teaching moments on the top. Now, I only bring hardcore people with me here to help out. No wimps, right? You guys know Miss Peck? She's a science coach. You know what she did last weekend? She ran a 30-mile race. So this is going to be like nothing for her. Up hills that were a lot bigger than this. And you know, Mr. Prinsey, and you guys know Mrs. Gilson, right? They're my tough mutters. Miss Gilson carried me for what, like 100 meters or something on her back. Yeah, oh yeah, she did. So I only bring hardcore people with me. But we're all going to get up that hill. Let's go. But I want to make sure you guys know it and have a chance to learn it here. In case when we're in a classroom, I'm not there, and who knows what's going to happen, right? So, this is a chunk of limestone, and it's a big old boulder on top of this hill. You know rivers flow from uphill to downhill, so where the heck did it come from, right? There's nothing above us where this could come from. This was brought here by a glacier and dropped, right, this chunk. So, this is a sedimentary rock. It sort of looks like an igneous, doesn't it? I bet if a lot of you look at it right away, you would say it looks like it's vesicular, right? Remember, vesicular means it has holes, gas pockets, air pockets. Love it. Well, this one has all these holes because of acid rain, which is when, especially when factories put chemicals into the air, and then it mixes with the water and creates acidic rainwater. So the acid rainwater, you know that acids will react with a couple of minerals. You got to know what they are. Talk to the person next to you. See if you can come up with the 2 minerals that react with acid.
She's videotaping us.
You got to put it on the table.
Calcite and what?
No.
Stay dry and some will feel the pain. Acid rain.
What's the other mineral besides calcite, Joe?
Okay, so ready. If you said calcite,
He wasn't ready.
time to listen again. If you said calcite, give yourself a pat on the back. Did anybody think of the other one? You remember? Not that one. That one's used to make acid, so that was a cool idea. Lindsay, you remember? Not that one. It's a good guess. Olivia, you know? Air high 5. That was awesome. The dolomite is the other one. You have to scratch it first. So this thing is loaded with calcite. That's what limestone is, sedimentary rock. Melvin, are you tuned in? I'm worried that you're missing important information. Now, Melvin put his water bottle in the freezer last night, didn't it? Right? He put it in the freezer. I can tell because I see ice. Right? That's my observation inference. Okay. So, Melvin, if you would have filled that thing all the way up last night, and put it in the freezer, what would it probably happen to your water bottle?
Can you repeat that, please?
If you were to fill that all the way up to the top and close it and put it in the freezer, what do you think would have happened to your water bottle?
It would have been frozen. All frozen.
Okay, it would probably have been frozen. What would anybody know? Anybody ever have this happen to them before? Rochelle, did that ever happen to you? Awesome. So it expands and it often breaks, right? Well, this rock, you see all the cracks in there? What happens is, you know, it snows here, right? And it rains and water gets in those cracks. And then in the winter, it freezes. And you know what happens when water freezes like that? It expands, right? And when it expands, it often breaks apart the rock. That's called frost wedging. And that's an important process in shaping the earth. It's a process we call physical weathering or mechanical weathering. And it's one of the main ones that will break. Hold up with that, Melvin. Just relax, all right? So we know that eventually it will break up into smaller pieces. All the soil that we see, a lot of it has sediment particles that came from rocks like this that water got in there, broke them apart, and they just get smaller and smaller and smaller. They tumble down the cliff, and as they tumble, they smash into each other in a process called abrasion. They will break down even more into smaller and smaller pieces, eventually forming soil. Okay, so we're going to make our way down, and an important lesson that can be